want to do AI. Maybe your manager is telling you you need to do something with AI. Maybe you're interested in AI. So from a developer perspective, it's a little bit overwhelming, especially if you're like me, you're kind of a more traditional Java developer. There's a lot, right? So if you go to the kind of the landscape, this is very similar to the CNCF landscape, right? Except it's even more. And this is a landscape that they built in 2024, so more than a year ago. So you can only imagine there's many more projects out there to work with AI. So for us as developers, it's kind of overwhelming, right? So here we can see kind of the average developer trying to download, run, experiment, and manage models, and then configure some sort of runtime, and then ensure maybe correct prompt templates, and integrate it in their code, and they're completely buried, right? So really, I mean, it is not that overwhelming if you kind of take a few steps back. So let's break it down a little bit. So the journey to developing with generative or agentic AI, because that's kind of the hype this year, of course, we can break it down into these 3 steps. So, you know, the first is maybe doing some ideation and prototyping, right? So you need to find a good model, an LLM, to work with. And then you want to try some stuff with it, because each model behaves differently. You have different outputs. They're also trained for different purposes, trained on different data. So you want to try it out a little bit and experiment. And then you want to, of course, integrate it into your code. You want to build something really interesting with AI. So that means finding the right stack. So if you're like me, you're a Java developer, and you see like AI is all about Python, we'll see later that that's not necessarily necessary to work with Python. You can do it with Java too. But then you need to connect with the model. You need to do maybe add your own data with RAG, and maybe do some agentic stuff with MCP, and so on and so forth. And then once you have built that, of course, it only has value when you put it into production, right? So you need to operationalize it. So of course, we need to deal with serving the model, hopefully not as a developer, but sometimes. But we need to deploy our application, and this is very much, you know, the realm of what we're familiar with cloud native computing, right? So let's start with the first step, which is you know, finding an LLM, trying to play around with it. So if you've played around with AI, you've probably done something maybe with ChatGPT or with Gemini or something, right? And that's a good step. That's a good place to start. But kind of the downside here is that these organizations are putting a lot of money into these models and into these serving platforms. And maybe right now they're still kind of cheap, but they're not really making that much money right now, because they want as much adoption as possible to then kind of lock you in, right? I mean, there's nothing wrong with that necessarily, but as you know, we're here, part of the Cloud Native Computing Foundation. We love open source, and this is, you know, nothing like open source, right? So, of course, this is something that we've seen before, right? So if we take a step back and think maybe this is a long time ago, but operating systems used to be all about proprietary big operating systems, and they were very expensive. And then kind of with Linux, that kind of got opened and democratized, right? So we've seen that with operating systems. We've seen that with application servers. And well, we've seen that when you know, cloud computing came on the scene, that Kubernetes kind of broke everything up, democratized it. And well, now we have this new kind of revolution with AI and ML. And you know, I think the key here is really that open source is central, is what is going to make this or break it, right? So if we, as you know, as a community, push forward with making sure that organizations focus on open source, I think there's a bright future. So if you want to start with open source, maybe find a model. You may have heard of Hugging Face, which is kind of this, let's say, the GitHub for LLMs, for large language models. And you can find a lot of interesting models there. And then you know, you go to a specific model, but open source, I put it in quotes, because you can see here, it's maybe very small, but if I go to this particular model, it's asking me to agree to share my contact information to access this model. And so with a lot of models, there's different variations of what they consider open source. So open source to me means we have free access to it, we are free to modify it, and so on and so forth. A lot of these models don't, but I think we're going in the right direction. So here's a couple examples. Of course, I'm a little bit partial to IBM, of course, but they have IBM Granite models, which are open source. The weights are open source. The sources that they're trained on are open source. So, you know, that's going in the right direction. And surprisingly, lately, we've seen that OpenAI, even though they have open in their name, there was not that much open about it. But we've seen that they released some new models that were, you know, that are at least more open source. And the CEO, you may know him, Sam Altman, he said recently that he believes OpenAI has been on the wrong side of history when it comes to open sourcing. So we see that these bigger organizations are moving more and more towards open source because it's the same evolution that we've seen with cloud native computing, right? So we have models, right? We can find them maybe on Hugging Face. Now we need to, you know, of course, try to use them, right? So how do we do that? Well, there's, you know, a lot of solutions out there. Some of the ones that that I like are, for example, if you like if you know about Podman, there's Podman Desktop, which is a way to run containers on your local machine. They have a cool extension which is called Podman AI Lab, and then you can actually just run models in a container in Podman. There's also kind of more, let's say, production-like environments like LLMD for serving models on production in a distributed way. Or there's, you know, Olama or Ramalama, which is another cool project where that allows you to run models in a container very easily. So, you know, you have some options to play around with it. So as a developer, this is kind of a good place to start. So we kind of have this ideation and prototyping out of the way. Now we want to actually build our applications, right? So like I said, we need to find the right stack and then connect with the model and do all that stuff. So for a developer, where do we get started? You know, some stacks do that a little bit easier, some not. Again, the way that maybe you can kind of break it down is that this is kind of my vision of this a view of working with models is you have this left of the model, which is more like the data scientists, right? So there you can see a lot of Python projects there to actually train models and to refine models and so on and so forth. But then you kind of have, you know, in the middle, the models that they have, you know, trained, maybe in your organization, or maybe you're using a model that's available. And then we, as application developers, are kind of right of the model on the right side, where we're actually using the models and bringing real value to the models, because if they're not being used in your applications, well, you know, there's not that much point to it, unless you're a vendor of LLMs, of course. So here you can see a couple interesting, you know, if you're a Python developer or a Java developer or a .NET developer, you see your little logos. So this particular project here with the cute little parrot is LangChain4j. And then I really like this Quarkus Java stack, which is developed, well, mostly within Red Hat and IBM. So again, maybe I'm a little bit partial. But it's a really cool project to kind of integrate AI into your applications. And so this goes beyond just kind of integrating LLMs. It allows you really to make sure that it's production ready, that it's enterprise ready. And you may have heard of agentic AI these days, and you may have heard of MCP. So this is something that you can do as a Java developer as well. So MCP allows you basically to connect external capabilities so your model can call them and do something, right? Because a model by itself can't do anything. But if you give it the capability to call tools and functions, then it's able to do that. And you can create these remote services. So here, this is a screenshot from Anthropic, who had, as the MCP client, this client.py. Well, I'm replacing that with LangChain4j as a Java-based MCP server. So I'm going to do a real quick demo to kind of show you how that works and how relatively easy that is. So I'm going to put the microphone down and I hope this works. Yes, excellent. All right, so I have my application here, and if you're a Java developer, this looks probably pretty familiar with to you. So here we have this extension, Quarkus MCP Server SSC, and by adding this extension to my application, I can actually create MCP servers with Java. And so you can see here that I have a couple MCP tools. So we have a tool called Get Historical Weather, and we have Get Available Devices, and we have a tool called Get Current Weather. And this actually connects to my weather station at home. So I can use a model to call my weather station at home and then get some interesting information. So I'm going to start this up on my local machine. So I can do this in this Quarkus dev mode. And then on the other side, I also have a client. So here we have another Java project that is a client that's connecting to a model. So we have this dependency length chain for OpenAI, and I'm not using OpenAI. I'm actually using a local model, but it's an OpenAI based specification. So this is, you can see here my configuration that I have an MCP server that I'm plugging in, and then I also have a base URL for an LLM. And so if I start this up, I'm going to connect to a model running on my local machine, and connect to the MCP server that I also just started up. So let's see if this works. All right, here I have my chatbot, right? Because we all, of course, want chatbots these days. And now let's see if I can actually call the model and see if it can connect to my weather station at home in the Swiss Alps. So I can ask it, hey, what is the current temperature in my home in the Swiss Alps? And hopefully this works, right? Because it does need to go out to the internet. So this calls the model. The model notices that we gave it some tools to have available, and then it's actually coming back to my agent, going to the internet to the MCP server that connects to my weather station, and then I can see that it's 24 degrees at home right now. This is great. So we can create an AI chatbot, or any kind of AI system with agentic AI in pure Java, and then the nice thing is that we can use our real proven ways to deploy this to production. So you can see here that I actually have this MCP server running on OpenShift as well. If we can maybe log in, it looks like it logged me out. Let's see if this is going to go. Okay, because I was trying earlier and it was pretty slow. So this is the same MCP server that I've already deployed, and I deployed it with Knative. So you can see here there's 0 pods right now because I'm not actually using it. And I also plugged this in. So for example, you can use LM Studio or any other client and create a new chat, and then connect MCP server, and then same deal, right? So what is the current temperature? And this is going to go and wake up the pod here, the Knative service, and it's going to serve the MCP server to the AI system. So you can see that we can use the same kind of technologies that we're used to in our cloud native capabilities to also use AI, right? So hopefully this was kind of a demonstration of AI doesn't have to be that complicated. All right, so now I lost my clicker. We'll just use the screen here. So now we've created an application, we've built it, we integrate it with AI, and now, of course, we need to operationalize it, right? So this is where us as developers, we definitely have to work together with the rest of our team, right? Because AI at the end is a team initiative. Everybody has a role to play in AI. You can see the IT operations, they kind of span the whole thing. The application developer is involved with maybe not necessarily developing the model, but maybe giving some feedback to the data scientists. And then you can see everybody has their role. And if you want to create a platform where you can serve models, and maybe in your organization you want to train models and everything, of course there's all these projects, and you need to bring them together because having the individual projects doesn't make sense. We want to have a nice project that's together, and that's where, of course, some platform like Kubernetes is, again, the shining star to bring everything together. So one example project that kind of brings a lot of these tools together in a usable way is Open Data Hub, which, as Daniel said before when he was presenting Red Hat, this is an upstream project from Red Hat because Red Hat does everything open source and in the community, and then that is the basis for OpenShift AI. So there's some sessions later on about OpenShift AI, but this is kind of bringing everything together in a nice package for Kubernetes users without having to kind of select the individual pieces and bring them all together. And then finally, as a developer, there's also like, where do we find the models that are approved in our organization? Can I have some sort of template that already shows me how to connect with these models and how to do everything? So that's where projects like Backstage are really cool for organizations to put everything together so the developers don't have to go, and find in the huge landscape how to get started. So hopefully this was an interesting introduction to, for how application developers can work in a cloud-native way with AI. So kind of recapping it, AI is definitely an overwhelming thing, but with the right steps, maybe it's not as scary as it seems to get started. But things are evolving very rapidly, and I think open source is going to bring everything together where the communities can kind of converge, just like we did with Kubernetes. There were a lot of solutions before, and kind of we all converged and worked together on these solutions, which is why I think open source is key. And maybe I also showed you that traditional stacks like Java can do AI too, and Cloud Native Computing Foundation and the Cloud Native in general is more relevant than ever to enable AI development and deployment. So with that, I thank you very much. You can find the slides on that QR code, and see you later.